Fosion are now part of Excelitas Technologies, which is a photonics group. Everything to do with emission, transmission, and detection of light. I'm going to talk a little bit today about how I became wavelength agnostic and really how we can optimize single pass inkjet curing for packaging. So let's go on a little bit about that. Who is Excelitas? Well, it now comprises Fosion, Noble-Light, Omnicure, Fusion. Some of you will know more, one or all of these companies, but we're all under one roof now. So let me be honest with you. I've been an advocate for UV LED. We were the first to introduce UV LED technology for industrial applications in the industry. And for over 20 years since we founded Fosion, Fosion was sold. I was a technology fundamentalist. But I've quite literally seen the light and become wavelength and technology agnostic. And I've had it kind of forced on me. So what do I mean by that, and how does that benefit the people in this room here? So if we consider the options that are available for drying and curing, and what we say is IR dries and UV cures, and what we can say now is if we look at what we've got, we have LED solutions, long bars. The lamp at the bottom there is the one we supply to Heidelberg on their sheet-fed offset presses. We do the standard, what we would call standard LED type light sources, which are used extensively in inkjet printing. But we also now have the light hammer type microwave systems, the standard UV bulb technology. We have excimer technology down to, I think, is it 172 nanometers. But we also now have IR technology from medium, short, and long wave IR up to carbon emitter technology, which I think is about 2.2 micrometers. So there's a whole broad range and suite of solutions all available from one source. So when we look at the optimum ink drying and curing, is the key to faster press speed and a more efficient process, right? So if we look at, there is increasing pressure on material suppliers to comply with ever-changing legislation, RoHS, REACH, and this can limit the availability of some materials, and the goalposts are moving. So what's here one year may not be there the next. So it keeps changing. So full system solutions, what I mean by in one type of drying or curing technology, may not be available or practical for a single drying or curing system. So people have to look potentially at, there's this dilemma then for the print OEMs and the print service providers. So what is the optimum drying or curing system for my print process? Should I choose IR or UV? Should I choose mercury or LED? Do I need to be low migration compliant? There are even like local energy supply restrictions. We have people who can't add capacity into the factories because the substation just won't supply any more power without adding an additional substation. So there are a lot of factors that go into making decisions about how you're going to actually dry or cure your print process. So how do IR and UV help to increase the energy efficiency of your process? So modern infrared and UV curing can be focused precisely at the product and does not require standby operation like some conventional technologies. So they can be switched on, off as you need them. This precise coordination saves unnecessary energy losses and heat generation in the environment. We have fast reaction times for IR and UV energy, only where and when it is needed. And if we look at the case for IR on packaging and porous substrates, water-based color challenge. So the difference in energy absorption by pigments causes differential drying. And so if we look at things like our carbon emitter technology, which is literally a strip of like carbon fiber within that tube there, and that heats up to this, I think it's 2.2 micrometers heat wavelength, and that will sync better with yellow and black in terms of your printing so that you can get better drying of that compared to, say, using an NIR type system. Not many people supply that type of technology. It's quite innovative. And this is what we call a colorblind solution. So it's less sensitive to changes in color, so it can be used right across the board. And also beneficial for drying water-based top coats, overprint varnish for the same reasons. So water-based advantages in terms of food contact compliance, you can have very thin layers, high flexibility. If we look at the case for UV LED, there are UV challenges in terms of food compliance and some limitations on inks and coatings. Some of the big advantages, which have already been spoken about as well about UV, is it's instant on-off, it's less substrate dependent, it's very energy efficient, and you can produce with sort of higher mechanical and chemical resistant printing. So we've seen, now that we've brought all these companies together and part of our mission is to try and look at full system selling solutions, we've come across opportunities where people have said, well, I want to put a water-based primer on my UV inkjet printing system, and so I want an IR system for the primer, I want a LED pinning system for the CMYK, and by the way, we might want to do some surface modification to the final print, to the overprint varnish. We might want to put an excimer lamp on there. So normally you would probably have had to go into 4 different companies to do all these things. Now we have the capability of supplying all these different solutions all the way through the process, all from one supplier, which is quite unique. So gone through that. So Excelitas, it's Phosion, it's Omnicure, it's Noble Light, which some people also know as Heraeus, but that's all under one company now. And that's the end of my presentations. We know curing and drying. Thank you.